In the last topic, I'm going to go over how to find outliers. So in order to find outliers from a data set, you want to calculate the IQR, which is the interquartile range, which is Q3, and then you subtract Q1. Then you're going to compute the lower bound and the upper bound using these two formulas. And so if you have a data value in the data set that falls below the lower bound or above the upper bound, then it's outside what we would consider a normal range, and we would call that an outlier. So in this example, we're going to practice again finding the 5-number summary, drawing the box plot, and finding the IQR. But then we're going to apply how to find outliers in the last part of this example. So to find the 5-number summary, we're going to hop over to GeoGebra and put the data in spreadsheet view. So here's my data for this example, and this is in column B. Now I want to find the 5-number summary for this data set. So I'm going to highlight the data set, choose one variable stacks, and then, or actually I think it's one variable analysis. And then choose this icon over here with the sigma and the X, and I'll get my 5-number summary. So my minimum is 3. My first quartile is 6, which means approximately 25% of the data falls below 6 or is less than 6. My median is 7.5, which means approximately half of the data set is less than 7.5. And then my Q3 is 11, which means approximately 75% of the data is less than 11. And then here's my maximum value, which is 30. So now that we have our 5-number summary, I have a minimum of 3 and a maximum of 30. So I'm going to draw my number line so that it goes from 0 to 35. I'm going to go on a scale of 5s. I'm going to draw my box first, and the length of the box goes from Q1 to Q3. So that's going to go from 6, which is about right here, to 11, which is about right here. So there's the box. Now I have a median at 7.5, so that's going to be about right here. That's where the median is. And then my minimum and my maximum is going to how I draw my whiskers. My whiskers are going to come out to the minimum and the maximum. So here's my minimum approximately at 3, and then my maximum is at 30. So this is what I mean by not all box plots are going to look the same, but they're going to have the same characteristics. They're all going to have a box with a line down the middle, and they're all going to have whiskers that come out. However, some might be stretched out in different parts. And that just tells us that the data is more spread out in that area. So between 11 and 30, there's a pretty good spread of data, even though 25% of the data falls between 11 and 30. All right, now we need to determine the interquartile range. So the interquartile range, that's the range of the middle 50% of the box. So the interquartile range is the distance of the middle 50%. So we're going to take Q3, which is 11, and we're going to subtract 6, which is the Q1. And that's going to give us 5. So that's my interquartile range. And we're going to use that for part C to find where the cutoffs are for possible outliers. So if we look back up here for part C, here are the formulas that we need to find our lower and upper bound to find outliers. So to find the lower bound, I take Q1 and I subtract 1.5 times the interquartile range. For the upper bound, I take Q3 and add 1.5 times the interquartile range. So let's do that. So for the lower bound, We have Q1, which was 6. So we have Q1 minus 1.5 times the interquartile range, which is 6 minus 1.5 times 5. When we work that on the calculator, we're going to get a negative 1.5. Now let's check out the upper bound. The upper bound is when you take Q3 plus 1.5 times the interquartile range. So Q3 is 11. So we're going to take 11 plus 1.5 times the interquartile range. So we're going to take 11 plus 1.5 times 5. And that's going to give us 18.5. So what does this tell us? If there are any values less than negative 1.5 in the data set, it would be an outlier. That would be when you're checking it against the lower bound. Now, when you're checking it against the upper bound, if you have anything bigger than that upper bound, so if there are any values bigger than our upper bound, which we just calculated to be 18.5, then that value would be an outlier. So looking at the data set, we don't have any negative numbers, so we don't have any outliers on the lower end that's way past the data set to the left, unusually small. But we do have a value that's unusually big for the data set. We have 30. 30 is past 18.5. We also have 20. Let's see, do we have any more? We have 25. I'm not seeing any more. So we have 3 outliers that are unusually big compared to the rest of the data. So for the lower bound, we would say we would have no outliers. But for the upper bound, we have 20, 25, and 30. So these numbers are unusually big compared to the rest of the data set.